So you might have heard that Kubernetes and containers have gone mainstream. But the security side of things isn't so popular yet, and there are a number of threat vectors that you have to consider, from the underlying hosts, the cluster components, which includes your control plane, data plane, and worker plane. You also have to think about authentication and authorization, not to mention the actual workloads running on your cluster. And you'll find that the deeper that you dive, the more details you'll find. Now in this video, I want to talk about one of the ways that you can secure your hosts in Kubernetes, specifically using AppArmor. I should mention that there are other tools that you can consider for this approach, such as Secomp and SE Linux. Now, I'll demonstrate this with a K3s cluster, but you can certainly implement this with other Kubernetes distros too. AppArmor is a Linux security kernel module that gives you granular access control for the different programs that are running on your systems. As you would imagine, this is pretty important when it comes to running containers. You want to protect yourself from potentially malicious software, or in the case that an attacker compromises a program or process running on your machine. You can make use of AppArmor to control and limit what a program is allowed to do on your host's operating systems. To do that, you would use what are known as profiles. And these are basically rules that you can define to stipulate what a program can and cannot do on your machines. These profiles can be loaded on AppArmor at the server level and activated either in complain mode or enforce mode. Complain mode is used to discover what the program is actually doing on your hosts, whereas enforce mode, as the name implies, actually enforces the rules and prevents programs from doing anything that they shouldn't be allowed to do. Now, in the context of Kubernetes, these profiles have to be loaded and enabled on the different nodes or servers where your pods could potentially be scheduled. So that means you would have to have AppArmor set up on each of them. Most Linux hosts should have AppArmor installed and enabled, but there's no harm in double checking. Now, in the case you're worried about having to access every host in your cluster to load these profiles, you can use Kubernetes to manage and propagate this process through the use of config maps and daemon sets. Daemon sets are pods that are scheduled to run on every one of your nodes, and config maps are used to store configuration data in your cluster. So the config maps can store the AppArmor profiles, and the daemon sets can be used to load these profiles on all your nodes. Let's take a look at this in action. All right, so I'm inside my terminal, and just so you're aware of what my cluster setup looks like, I'm going to run kubectl get nodes, and you'll see that I have a single server and 2 agents for my K3s cluster. And what I'll proceed to do is I will create a config map, and in that config map, there will be configuration data specifically for an AppArmor profile that will restrict rules for any containers or pods that will attempt to write to the disk. And I will then use a daemon set to implement that by sourcing that particular config map. And lastly, I will test that out with a particular pod that will try to write to a particular log file. So for starters, we can take a look at the config map, and you'll see over here that this is going to be created inside of the AppArmor namespace, and I've called it AppArmor profiles. Now, specifically under the data section, I have this profile, and I've called it K3s AppArmor deny writes, and this is a basic example that you can easily find online as well. You'll find that as you have specific requirements, you should probably create rules that meet those particular requirements as you implement this. But this could definitely give you a good idea of how to do this. And so as you can see over here, this is going to deny all file writes. And so the next thing is to take a look at the daemon set. And thankfully, we can follow this approach with actually using containers because there is an existing image for AppArmor, as you can see, the AppArmor loader. And this is also going to be created in the AppArmor namespace, and I've just called it AppArmor loader to make things easy and from a naming perspective. And so if you were directly interacting with your host and you wanted to load the profiles, that would be done inside of the etc AppArmor.d directory. And so I am mounting the sys directory and specifically this same path because that is where I want my profile data to be loaded. And so as you can see right at the bottom over here, I am sourcing the profiles from that same config map that I just showed you, AppArmor profiles, and so that will be loaded on the underlying host. Now, once that has been done, the last thing will be to create some form of a test to make sure this is actually working. And as you can see over here, this is a very basic pod. I'm calling it AppArmor disk write. And before I get to the container configuration data, the annotations is probably the most important part to make sure that things work as expected. This first part, which is essentially your prefix, is a requirement in order for this to work as expected. You need to make sure you have the specification of container AppArmor security beta kubernetes.io, and then it should be followed by the particular container that you are implementing. And then lastly will be localhost for the particular underlying host, and then the name of the profile that you want to implement, which is, in my case, is K3s AppArmor deny writes. Now, under the container configuration data, I'm just using a busybox image, and the specific command that I'm executing over here is to an attempt to write to the disk, specifically a diskwrite.log file. And so now I'm going to create each of these. Now that all of my resources have been created, I'm simply going to run a log command against that pod. And as you can see, it's actually working as expected. I get the permission denied because of the rule that I have in place based on the particular profile that I loaded. Thanks a lot for watching. I hope you found that helpful. If you're interested in learning more about Kubernetes security, be sure to sign up for our free webinar, Introduction to Kubernetes Security and NuVector.